Hello, everyone, and welcome to an exciting new episode of the Tech Cafe podcast, streaming live on LinkedIn and YouTube. I'm your host, 𝗦𝗽𝗲𝗶𝗶𝗴, and I'm thrilled to be here with my co-host and friend, 𝗦𝗽𝗲𝗀𝗀𝗃𝗏. Today, we have a fantastic guest speaker, the one and only Daniel Moka, joining us to dive deep into mutation testing and test-driven development. Daniel, thank you so much for being with us today.
Thank you too. Hey, everyone.
Daniel is a true software craftsman and boundary pusher, passionate about raising the global standard of software quality. He's helped countless developers and companies master TDD, extreme programming, and clean code, all while leveraging cutting-edge technologies to make customers happy. In addition to his craftsmanship, Daniel has been a speaker at the first International TDD Conference and co-authored the TDD Manifesto. He also co-organizes the Tech Excellence Meetup, where I had the honor of presenting a session on TDD anti-patterns. Before we kick things off, let me give you a quick intro to Tech Cafe. Our podcast launched in March 2023 with a mission to empower the tech community and spark innovation. In 39 episodes, we have hosted incredible guest speakers, including Jeff Langer, Venkat Subramaniam, Paige Watson, and many more, covering a wide range of topics, including extreme programming, test-driven development, software architecture, and artificial intelligence. So a big thank you to all of our guest speakers. Last year, we were proud to partner with Startups Without Borders and Impact, as well as sponsor the DevOps Days Cairo event. This year, we're thrilled to announce a new partnership with the Riyadh Java User Group. Stay tuned. Exciting joint sessions are coming very soon. To learn more about Tech Cafe, catch up on previous episodes, or reach out to us, visit our website. We're always excited to connect with you. Now, without further ado, let's hand it over to Daniel to guide us through the world of mutation testing. Daniel, mic is all yours.
Thank you very much. All right, so welcome everyone, and thanks again for introducing me. And today we're going to talk about test-driven development and mutation testing. Let's get started. So first of all, let's see what will be the agenda of this talk, of this session. First of all, I'm going to introduce mutation testing. I'm going to talk about what is it, how we can use it, what are the reasons we can achieve high-quality software with it. After that, I'm going to do a demo about this. I'm going to use the Visual Studio and C# and the .NET Stack to demonstrate how you can execute mutation testing on your projects. After that, we're going to talk about a bit of theory of TDD, and we will talk why it is the ultimate solution to write high-quality software, which has the highest quality test suite we can rely on. And right then, I'm going to demo it as well, why TDD is the best way to write code. So we are going to design code by using test-driven development. And finally, we are going to have a Q&A session. So yes, Ahmed also said, if you have any questions about this, please feel free to drop it in the chat sections of YouTube. And at the end, I'm happy to answer any of your questions. So mutation testing, what is it? So first of all, before we get into mutation testing, let's talk about code coverage. We need to understand what code coverage is, because we can understand mutation testing only if we understand code coverage. So first of all, code coverage is a misleading metric. It is not a quality metric. Code coverage can help detect untested areas of the code, but it tells nothing about the tested areas. So basically, code coverage is just a percentage of your code executed by your test. That's it, nothing else, just the percentage of your code executed. So there is no behaviors involved when you execute code coverage. And because of that, we can achieve 100% code coverage without any test assertions. And if you don't understand this last line, then let me demonstrate it. So again, we can achieve 100% code coverage without any test assertions which are in your tests. So so let's demonstrate it. First of all, imagine you have a code with 100% code coverage. Or you can also imagine the projects you are working on for your clients or for your employees, for employers, and you can think about your project, which can be 90. The code coverage can be 90, 85, or 95%. Doesn't matter. Something high value. Just think about it. Have a reference. And now imagine that you delete all the assertion statements in your tests. You deleted it, and now run your code coverage tool again. And if you look at the result, you will see the same code coverage. So 100% or 95 or the one you had before. So this shows that you can have really 100% code coverage without any test assertions. So it's not a quality metric. So if you have a code with 100% code coverage, I don't trust it. And you shouldn't trust it. You shouldn't trust it either. So now let's talk about mutation testing. So what is it and why it solves the problem that is not solved by code coverage? So mutation testing is a testing type where you modify the source code. You do a small modification. We can also call it that you introduce a bug, a small bug in the code. We call it mutants. That's why mutation testing. And after that, once you introduce the modification in the code, you run all your tests. And if you at least have one, if you at least have one failing test, then it means your tests are able to catch this bug or this modification you just introduced. So your test suite is strong enough to catch the bug in the code. Or if all your tests are green, then they are not strong enough. So it means you have a missing test or a test assertions. So what are the different types of mutations? There are a lot of kind of, and the four most important one is, first of all, we have the operator mutations. For example, you replace a plus with a minus. It's arithmetic operation. You can have a conditional mutations. For example, you negate a Boolean, right? You change it true to false or the other way around. You can have statement mutations where you delete a line of code, for example. And finally, we can have value mutations where you, for example, alter a function returns value. For example, if it returns a string, then you change it to null. For example, in C# where a string can be null. Or if it returns 10, you change it to returning 5. So how can you going back? So how can we execute mutation tests? So we can do it manually, right? I mean, it's manually. It's very easy. You can just go to your code. You just do a small one of these changes I just mentioned, and after that you run your test, and you see whether you have one failing test or not. If you have one failing test, you are very good. If not, then you have room for improvement in your test suite. But of course, it can be time-consuming to do this all the time, repeatedly for a large code base. So that's why we use frameworks. And what the frameworks do, that they generate a big number of mutations for your code, as high as it's possible. And after that, it checks for each mutation, it checks whether your test suite is strong enough. And from this, it calculates a metric called mutation score. And this mutation score, it really measures the quality of your tests. So the higher it is, the better. So how can we calculate this mutation score? So again, as I already mentioned, that every mutant generated, we run, or the framework runs all your tests and checks that if there is at least one failing test, it means it's a killed mutant. Or if there is no failing test, it means survived mutants. So we have killed mutants or survived mutants. And easily we can just calculate the mutation score by dividing the number of killed mutants by number of all mutants and multiplied by 100. So it's a percentage metric. And if you have 100%, then it has way much more information about the quality of your test. And if you have 100% mutation score, or close to that, of course, then you can trust your tests. But if you have 100% code coverage, you cannot trust your tests. Be careful. So now, it's demo time. So no, it was a theory, but let's see how it works. I will show you the money and how you can use mutation testing in a real life project. So if you can change the screen, please, Ahmed, that would be appreciated. Thank you very much. So here we are. So before we get into the coding, let's talk about the real life project. I grabbed, as I said, from a real life scenario, and let's see what is it. So basically, it's a warehouse management system. So there's a system that was implemented, and we are going to use mutation testing. So what is it? What is a warehouse management system? A warehouse management system is a tool that helps control and organize everything that goes on in the warehouse. It helps keep track of products and manage their storage. And the system includes managing inventory, organizing storage space, and coordinating the logistics of sending and receiving goods. So as you see here in this picture, this is a warehouse. I bet most of you have seen this or been there physically. And the project which is implemented here is basically this, what you see. So as you see on the top, we have a front end. Of course, it's for the supervisors and everyone who is working in the warehouse to manage the different products in the warehouse. We have which is connected to a backend, which is called warehousing service. It's a web API. And you see also on the left, there are some hand scanners, which are used by the workers who are walking here up and down and scanning products, picking products, unpicking products, collecting products, gathering products for different kind of logistics and delivering to the customers. So this is the warehousing service, which is basically the core of our application. And this is a project we're going to work on and execute mutation tests. There are already a few features implemented for this warehouse. Namely, there is a product endpoint. And it contains different functionalities such as creating products, retrieving products, searching for products, and picking products. I think the first three is understandable, but maybe the fourth one is not understandable. Everyone, so what picking means? Picking means is that, let's say, if there is an order by a customer, and what the workers do on the floor, they check the order. They say, okay, I have to gather 10 of a given kind of product based on order. Then they go to the warehouse. They find the product's location. They go there and they pick the products and they take off from the shelf. And after that, they will put it in the logistics and it will be delivered to the users. So this is what picking means. So as you see, we already have a few features implemented. So now let's look at the code. So here we are. So first of all, what I'm using Visual Studio. On the right side, you can see the Solution Explorer. And it contains two projects, the Mutation Testing Meetup and another one, Mutation Testing Meetup Tests, where my tests reside. And so as you see here, this Mutation Testing Meetup, the production code contains a few folders, application data, and domain. Just a side note, usually I use feature-based folder structure and other kind of structurization of the application. But for now, I'm just using application data domain just to keep the thing simple. Surely the application folder contains the things about my controller. So the web API endpoints. The data contains the data layer, the repositories and the data entries, unit of work. And the domain, of course, contains the domain entities and also with a bit of domain-driven design, so rich domains and all these things. So let's look at the code. The most important part is the products controller. Basically, what we see here is that where the endpoint is implemented. But before we check the code, let's look at the left side. We have this 𝗠𝘂𝘁𝗁 on the left, as you see, and you see a lot of green check marks. So these are all my tests. And this 𝗠𝘂𝘁𝗁 is a tool which executes my test every time when I change the code. So even if I just change one keystroke, it will run all my tests. So it means I never need to manually trigger my tests. So I highly recommend this tool. It's called 𝗠𝘂𝘁𝗁. You can use it in Visual Studio. You can also use it for, I think, the Rider from JetBrains. But if you use JavaScript or other development environments, I'm sure you can find similar tools. They are called continuous test runners. So basically, they keep executing your test all the time. And I think this is, I wouldn't say requirement, that's very, very helpful tool for especially if you follow the test-driven development. So product controller, as you see, we have a few dependencies. Doesn't matter, unit of work, products finder with some logic to find the products. Surely we have a get endpoint where we get the product, right? And what we do is we get the product, we check whether the product is null. If so, we say it's not found. So the product is not found with the given ID. And after that, if it's found, then we return awk 200 status code with the product in the body. Very good. We have a get products, which is a search endpoint where, as you see, you can specify some products, query parameters, different kind of parameters, implementation details, not so necessary right now. Later on, we can check it out. And basically searches for products based on your query parameters. So again, here we check whether the category is filled. If not filled, then we return bad request. It's sort of business requirement we needed to implement. And but if it is provided, then we use the products finder logic class, and we get the products and we return it in a 200. Going on, we have a create product. Again, not so interesting, but we don't need to go very much into details. We check whether the product exists with a name. If it exists, of course, we cannot create with the same name. Otherwise, we just create a product, we push it, commit, and that's it. And we return the product, of course, back with the created status code. And we have one more, the last endpoint, which is pick product, which I already mentioned, picking products, gathering, collecting based on order. We can call it the ID/pick. And what we do is we get it, we pick. Let's see what is pick. So now I'm going to open the product domain entity. So pick means we change the last pick state to some picked, that is last, and we raise a domain event, which is product picked event. And here sort of the event handling is decoupled. Here the product picked event handling, of course, is decoupled from the domain entity because we will do some database operations there, and we can see it right away. So if I product picked event handler, and here if you look at it, what we do is that every time when the product is picked, then we get the stock level and we decrease it. But of course, if we pick more than the stock level, which is physically not possible, right? We cannot, let's say, if we have in a warehouse, we have 8 of a given product, we cannot pick 10, so we should throw an error. It's an application exception. All right, going back to the product, as you see, so again, it has a name, it has a category, it has a price, some sales state, whether it's on sale or not. And we have a pick state. What is the last pick state? We have a constructor, and here we raise an event, product created event. And what happens when the product is created, that's also a business requirement, that every time when it's created, we create a stock level with initial stock level, which is on the top, you can see 10. So every time it's a business requirement, every time when a product is created in our warehouse, then 10 physical products needs to be put in the warehouse. So that's how our production methodology works. Very good. So now we have this. We have the production code. And of course, the most important part, the second most important part, we have tests for that. So let's look at it. So I have plenty of tests. I have a lot of tests. And these are high-level tests, but still sort of unit tests, but very high level. So we have, for example, first test, get products should return not found when no product exists. Yeah, straightforward. And here, just explanation what I do. First of all, I create a scope, in-memory test server scope. So what it does, it spins up the HTTP web server in the memory, the endpoint itself. And this scope has also a client, as you see in this line 20, I can use to fire my request to the web server. So in this case, I'm doing the client, I'm doing the get product endpoint with a given ID, and I should get a product. But here, I have this HTTP response asserter, which says assert that response has status code, HTTP status code not found, because nothing is stored in the database. And that's what this test says. Going to the next test, get product should return product when product exists. Yeah, we don't need to go on. But what I just, I create a product in the database. Again, I call in the get endpoint and I check whether something is returned in the response. All right. Again, get all products should return bad request when no category is specified. This one I already explained in the production code that we have this requirement. Going on, get all should return no product when nothing found in category. Yeah, not so interesting. Yeah, get all should return single product when single found with filters. So here, we are using the filtering logic to search for the products. Yeah, implementation not necessary to check. Product should be created when no product exists with the name. Yeah, again, we create a test scope, we create a new product, we fire a post with a product endpoint with a given payload, and we check whether it is created. Again, not so interesting. Should return conflict when product with name already exists. Yeah, we already discussed. Pick product. Yeah, it's important one. Pick product should decrease stock level. Yeah, that's what we already discussed, right? Picking a product based on order, we take it from the shelf of the warehouse, and it should decrease the stock level. And as you see, we have here the logic. We create a product in a database. We call the product with the ID and pick. And after that, we assert that it's really no content is returned and the stock level has been decreased. And we also have for the error case. So as you see, I have a lot of tests, right? So it's seems like pretty much the functionality is covered. So now let's look at the code coverage of this project. Here in the top, I can click on 𝗠𝘂𝘁𝗁𝗁, this tool I already mentioned, this continuous test runner, but it also has side feature or sub feature to check the code coverage. So if I open it, unfortunately I cannot increase it, but I hope many of you see this. So it is 97%. So right now we have 97% code coverage. So we should be happy, right? And usually when you have it in other companies, or basically in most companies, they are super happy if there's 97 and they trust their code. So now let's demonstrate that why it's not a quality metric. So know what I'm going to do. Let me just decrease a bit. I'm going to remove all the assertion statements of my test, as I already mentioned, in the slide sheet. But now I'm doing it again. So now I'm removing all the assertions of my test, all of them. Let's remove, right? So yeah, and yeah. So now you see I have tests, but they don't test anything. They call the code, but they don't check anything. And now let's see let's check again the code coverage. And if you look at it, as you see, we have almost the same, right? 96.7, so 97%. So we have the same coverage than before. But our tests don't test anything. They have zero assertion statements. So whatever you do in the code, they were not going to catch it. So again, can we trust our test? Can we trust our test with the 97 code coverage? Yeah, the answer is not. Unfortunately, we cannot. Code coverage won't help. So, and what will help? Mutation testing. And now I'm going to show you how you can use mutation testing on this and to find out how to improve. Basically, first of all, let's see whether our tests are good enough or not. So now let me revert this because I want to have assertions. Definitely, I want to have. Yeah. And to execute mutation testing for .NET, I'm going to use the tool striker. Let me grab it. Striker mutation testing. Just grab it on the screen just quickly, just to see. So I'm going to use this tool, striker mutator.io, here in the direction and playground. You can check it out. You can read a lot about mutation testing. I think it's one of the best documentation about mutation testing, the striker mutator. Not only the tool is one of the best, I would say it's the best tool if you have JavaScript, C# or Scala. So it's not only the best tool, but also it has the best documentation of mutation testing. So if you want to read more about mutation testing, different kinds of mutations, because I mentioned only 4, but there are like more than 30, then check this out. So surely I'm going to use this. And for that, I have to grab the command line interface. And before we get into, I'm going to show you so before I run the command, because it's just a command line tool, I'm going to show the config. So this config in a test project. So this is used when you run the command. And let me open it with Notepad. Yeah, here we are. So as you see, the striker config, we have reporters, two kind of. First of all, we want to have a progress on the CLI. So see, how is the progress of my mutation testing execution. And we want to have an HTML. And I would say this is the killing feature of the striker. And unfortunately, this feature doesn't exist in other mutation testing tools. At least I'm not aware of any. So, and you will see really soon that this is really handy, and it can really visualize your mutations and the status and the executions of your mutations. Of course, I'm using the solution and the project, which is straightforward. I also use what not to mutate. For example, of course, when you do mutation testing, your whole code base will be mutated. And there are some classes you don't want to mutate. For example, the startup.cs or db context configurator or program.cs or whatever, some infrastructure code or something you really don't want to do mutations because there is no business logic or it's not necessary to do mutations. Then you can ignore them and you can configure this in a Striker Mutator, but also you can also configure it in other tools. And we have thresholds, which says, what is the mutation score, what is a high mutation score, low, or break. Very good. So this will be used. And now let me then run the mutation testing. So what we need to do, .NET, Striker, and I'm running. Yeah, you see it's getting. Now it's analyzing the project. And now it's building the project, as you see. Initial test run started. Wait it out. Yeah, you see 139 mutants created. We have a few which are not no coverage or ignored or no compile error. I mentioned they are ignoring. Surely we have 68 mutations. So 68 modifications of the code has been generated. And what the framework does right now, that for each, it checks, it does that small modification, mutants, so in case that small mutants, and runs all the tests. And this tool does it for every mutations. And as it took half minute for 68 mutations. So it's a relative time-consuming process, but surely it has been finished. And as you see, we have this number as a result, 78.87%. And again, the code coverage, we had 97. And now we have mutation score 78. So it's sort of 20% less. So now this mutation testing score result tells us, something is wrong with our tests. And the question is, what is wrong? And I'm going to show it right away. So this tool created here in the Striker output, it created a new folder, the last one. It reports, I mentioned, I showed in a config that we specify the HTML as a report. And this is the mutation report where we can visually see all the mutation mutants and their status, whether they have been killed or survived. So if I open it, basically that's it. As you see here, we can see the folder structure and the project. We have the application, the control layers. We have the data layer and the domain layer. Let's first look at what happens to the control layers. As you see, so all in all, we have 78%, but in the control layers, what I have shown, the control layers, where we have the endpoints, we have 97%, which is a quite good number, but still, it's 7% or 8% off. So the question is why and what we did wrong or what we missed. And if if I click on it, you see all the other classes, but surely we have the product control layers where we have the logic. And as you see, so this is what you see here. We have 13 killed, 1 survived, some timeouts, what is ignored, has been ignored, how much it has been detected, etc. The most important is we have 13 killed, 1 survived, which is a really good number. And here I can also check this box. So it will show all my killed, all my survived. So here, if you I can maybe zoom a bit just for you. Yeah, so here, as you see, we have this green dot. And if I click on it, it shows what it did. It shows the mutation. So what the framework did, it generated the mutation where it replaced these 4 lines where I initialize, the dependencies. It replaced completely here, as you see in the green line, it replaced to an empty block. It replaced to an empty block and ran all my tests. But it has been killed because it's a green one. So as you see, it's green. So, or again, we have the get product endpoint. Here we check for this green dot. It has been again killed. So what it did, if I click on it, then it did negating this. It was equal, so product equal null, and it changed it to product not equal to null. And it has been killed. It means that it changed it. It negated this, and it ran all the tests, and we have 1 failing test. But we can even figure this out. Maybe that's better to understand. So here we are again, the get product, right? Get product endpoint. I'm a product controller, get product endpoint. Let me zoom in. So what the framework did, so again, don't forget I have the ncrunch where my tests automatically running and executed here on the left side. So again, so what this framework did, it changed this equal to not equal and ran all my tests, and all my tests again running. And as you see on the left, 2x appeared. The 2 failing tests. It means that I'm doing, so and this is mutation testing. You have something, you have your code, you introduce an arbitrary bug, your artificial bug in your code, and you check whether your test is able to find it. And you see we have it. It's very good. So basically, that's what mutation testing, that's what the mutation testing frameworks are doing. They are doing this small modification, running all the tests, and after that, they collect the result and show it to you. So going back to the result, which is very here in the brief. Yeah, so it did this very good. So again, what it did here, it replaced an empty block. Here, get products. As you see here, one survived, which is the query parameters category has value. It was negated. You see. So it doesn't have value or value, and we have a failing test. Awesome. But here, as you see, we have a red dot. And this indicates the survived mutants. And this is the only survived mutants in this controller. Let's see what it did. So what it did, if I click on this red dot, so you see the changes that it replaced the string to an empty string. And I don't have a failing test for that. Let us do it in the code as well. So it went here, I guess. Yeah, it was that one. Yeah, just to check back. Yeah. So here, it came here, the framework. It removed this. And running, no, all my tests are running, as you see on the laptop. They have been executed. Everything is green again. So as you see here, I'm doing some change in the code. Namely, I remove totally the error message, which is important for the user or whoever is using the front end, whoever is using this API. I removed it. And you see we have all the tests green. It means my tests are not covering this behavior. And this change can easily happen. You can, when you do when you're resolving some merge conflict, introducing new feature or whatever, you can do such mistake easily. And if your test suite is not strong enough, you can easily introduce bugs in your code. So going back, so let's fix this. So now the problem is that we don't cover this behavior. So let's cover. And I think the easiest what we can do is we go to the corresponding test. I think this one, get all products should return bad requests when no category specified. As you see, this test looks good. We check whether the bad request is there, but we should also check whether in the body we have the string or the error message we expect. So here I'm using HTTP response assert that response has text in body, and I can put this in I can put that, what we had in the production code. And now again we have green test, but now if you go back, and again if I remove this, so again I do the same mutations. Then I have one failing test, you see? So now my test suite was strong enough to catch this bug, but before that it was not. And how I fixed it, I use mutation testing. I checked the mutation testing result. It showed me that, hey, here you have an uncovered behavior, and I could add it. Awesome. And this was the only one. So let's check what are the other survived mutants. So we are fine here. I think we fixed this. So let's check the products controller. No, not the products controller. Let's check going back. Let's check going back. So here we have the data layer. Let's ignore for now. Let's go for the domain. In the domain, we have two classes which did very poorly, like 66% or 62%, which are very low numbers. It means we have some tests for that, but we don't assert all the behaviors. So let's see, first of all, the product picked event handler. So here, again, we could check what was killed, but let's check what was survived. I think that's more important because that's where we need to fix. So there are two survived. First of all, if I click on this red dot, it shows that it changed the, bigger with a bigger or equal sign. It did this change in the code. So, and we don't have a failing test. So here we're missing an assertion or missing an edge case. Namely, we need an edge case where this, when we pick equal to the stock level, right? Because that's what it shows. That's what would kill these mutants. So let's fix it. So going there, I think it was here in product picked event handler. Yeah. So again, if I just show it, if I just put here an equal sign, you see all my test is green, and it's clearly a bug. So what I want to do is here, let's write a test for it, and for that, let's go to controllers. Let's find the test, and I think the test is somewhere we should have a picked. Pick product should decrease stock level. And what I want to do is right now we're picking with, so we have again, remember when we create a product, then on the stock we have 10 items, 10 units. So here in this test, I pick 2. I pick 2 products. It means the stock level should be 8. So now we should pick, the pick count should be equal to the stock level. So we know the stock level is 10, then we should pick 10, and the stock level will be then 0. So let's add this test, and I can either replicate this test or introduce the parameterized test, but let's do parameterized test because I prefer this in this case. So here pick count and int expected stock level. And what I want here, the pick count is I want to pass in here, and want the expected stock level, I want to put it here. Yeah, and the test case is first of all 2.8, right? That was previous. Let's see, you see all my tests are running. You see, it's beautiful. In this, during this session, I never executed my test manual. It's always being executed by this 𝗠𝘂𝘁𝗁. This is really one of the best tools I can recommend to you. So we can create one more test case where we pick 10 and the stock level should be 0. Very good. We have it. So now we cover this edge case, which is basically this part. We have here one more where, again, if I click on the red dot, then it says, it changes this string, replaces it with an empty string. So let's fix it. I think we can easily fix it. So what I want is a product controller, event handler. So we have this. So this is not covered. So product controller test, we have an error case. You see, pick product should return error when pick count is bigger than stock level. Again, you cannot pick more than stock level. Something has been gone wrong. The consistency of the products on the warehouse went wrong somehow. Surely you cannot pick more. So for that, but we need for error message, we need an assertions await HTTP response assert that response has text in JSON body, and I'm going to place this there. Yeah, very good. And now that has been covered. We could check it, but I already did in other things. I mean, as a double check, for example. But yeah, I can do it just surely. So you see, I remove it, and always I have a failing test, so it covers. Very good. Now let's go for the last one. So we fix here two survive mutants. So again, we improve the quality of our test by checking the survive mutants and improving them. So here the products finder. So again, it's a logic class. Based on the it has a find method, and based on the product's query parameters, what you specify, for example, max price or the category, or whether the product is on sale or not. So based on these parameters, it does some filtering logic. And let's see what is survive. First of all, as you see here, we have this products order by. So we have all the products, we do some filtering. So we get the products, we do the filtering. And it does for products order by the name. I want to order it by alphabetically. And if I click on it, it changes this order by to order by descending. You see, it calls a completely different method, but we don't have a failing test for that. So let's fix it. So it means we need a test where we return multiple products. I mean, the find logic, this products finder logic returns multiple products, so we can check whether they are alphabetically sorted. It seems like we don't have a test for it. So let's add it. Again, products controller. I think here we have a test. Let me just a bit scroll. Yeah, here we already have a test. Getter should return single product when single font with filters. So you see, we have test covering, but we should, it just says return single product when single font with the filters. We should have a test when it returns multiple products when multiple font with the filters. And so the multiple products, we can check whether they are alphabetically sorted. We don't check, but we check, what is returned in assertion. So here I'm just duplicating this test. Get on should return multiple products when multiple found with filters. So here what I need to do, as you see, we have two products. One is with the price 300, other is 600. And here we check with the products endpoint category electronic. So we search for electronic products. Max price should be 400, and whether it is on sale, yes. So what happens here is, you see the max price here, the price of the product too is Acer webcam. The price is 600, but we feel since we have a filter 400, it won't be returned. So that's why just one is returned. So we need to return two. So let's change it 350. So now it's won't be filter allowed. And we need to change the assertions, namely this will be the first product because Acer, alphabetically should be earlier than the Logitech HD Pro webcam. So here I'm adding that stuff here. The name should be this, the product to ID. I guess. Yeah, and yeah, I think the price should be also correspond. Yeah, you see it's green. Very good. So now we fix it. Now we have multiple, and now they are in order. So now if we would change that logic, so namely if we would go back here, I mean in the code, and we change it order by ascending, it would have a failing test, which is good, because right now we have two products in the return JSON. So if someone changes this code, or the mutation testing framework changes this order by to order by descending, then of course that assertions what we just added. So this, this we offset the JSON error in body, then this will fail. Of course, this won't be correct because in alphabetical order. Cool. Let's go on the next one. We filter by max price if specified. And here, if I click on the red dot again, then you see it removes the equal sign and just a smaller, and basically we don't have failing test. Again, we don't check for edge cases, and I think we can easily fix it by here we can just change this 350 to 400, so we will be on the edge, right? So 400 is the max price what is specified, and this should be also for 400. So we know with the edge, so I think it has been easily fixed, because now that would fail. And yeah, very good. And basically the last one, the is on sale, we have this filter by is on sale. Filter by is on sale if specified. So we check whether it's specified. If so, then we filter it. But as you see, it basically we're changing it. I mean, the framework changes it or not. It doesn't matter. We don't have a failing test. We don't cover this behavior. So let's fix it. And I think the way how we could fix it is when we in the database, we should put a product with the price smaller than 400. I mean, going back to this example. So here I need to add a new product which should be there in the list, but should be filtered out because it is not on sale. Because as you see again in this, if you see this 122 line, is on sale is true. So we want to get the discounted products. So product 3, and it should be 400, that's true, or 350, but this should be no sale. Awesome. So now we fix it. So now again, we create a new product, which is still smaller than 400. So it should be returned, but it is not on sale, but we want on sale products. Therefore, it shouldn't be there. So it should be filtered out in the products finder logic. So this. So now basically we fixed all these two, I think all these three, and basically that was it. So now I think as exercise, if we did everything well, I hope, then I hope we didn't miss anything. Let's run again. So we have 78%. .NET Striker. Let's run again everything what we had. And I think we are still on time. Very good. So now again, collecting, analyzing the project. Again, the 139 mutants created. We have 68 mutants again. And because we don't add any, we didn't add any production code, so there is nothing more to mutate. And again, now it will run the same mutants, and let's see the results we will have. So yeah, it's been again for every test, it runs all my tests. It creates a mutant, runs all the tests, checks whether there is one failing or not, and after that goes for the next one, So you can see it can be relatively time consuming, especially when you have a big project, but I have a solution for you for that. Let's see. So now, yeah, wait it out. Yeah, we have it. So now we have 78%. So we improved sort of 10%, which is which is much better. 87% is very much better. So let's see the mutation report, the last one. And the last one, if you look at it, so as you see now, we have 100% for up controller and also for the domain. The data, again, we ignored, right? So that's why we have this all files 87, because in the data, we didn't do any improvement. But right now, we didn't need it to worry about this. We ignored it. We concentrated on controllers and the domain. And most importantly, there, everything is 100%. Here, the controller and also the domain is 100%. It means all the behavior you have in the code, or the production code, has been properly tested. And now you can trust your test. If you see this, of course, you see 100 or close to 100, because there are situations when you cannot reach that. Then you should be, and you can be confident in your code and confident in your test suite. All right, that was mutation testing. And now let's talk about what is the ultimate solution. So again, the question can arise, okay, we had this code base. How did we do this? How did I create this code base? Or why? How did we reach this situation? Then we have a code and it has a lot of, we have a low mutation score and we need to fix a lot. So what happened? What did it go wrong? And the problem was that, and now I'm going to talk about what was the problem. Please let me, please, Ahmed, I would like to ask you to share the, yeah, very good, thank you. So the problem also, what is the ultimate solution? To prevent this having low mutation scores, so to reach a test suite where a mutation score is really maximized, 95% or 100. So what is the solution for that? The solution is test-driven development. First of all, let's talk about what is test-driven development, because I'm not sure that everyone knows that, but most of you surely. But yeah, so for me, test-driven development represents three things. It's a development, design, and the testing methodology. First is a development methodology because it contains the TDD cycle and the 3 laws of TDD. It provides a framework to write code in a short cycle-based way. It's a design methodology because it puts my production code under stress because we write the tests, and it really helps me to design code with the user in mind, because the tests are the first users. And of course, also we have the refactor cycle of the TDD, refactor phase of the TDD cycle, which is one of the most important one, where we improve the design gradually by practicing continuous refactoring in small steps. And of course, it's a testing methodology, and don't believe anyone who says TDD has nothing to do with testing, because it has a lot to do with testing. First of all, you write code by writing automated tests, so surely it has a lot to do with testing. And second, if you use TDD, then you will end up with a test suite which will cover all the business functionalities properly, 100%, yeah, 95% or really high, maximize code coverage, maximize mutation score. This is a byproduct of TDD. It means, of course, you need to do other testings, I don't know, property-based testings, integration testing, user testing, and there are a lot of other important testing, but still the unit test will be covered by, most of the unit tests will be covered by the TDD flow. So let's talk about the 3 laws of TDD, and let's understand why TDD really solves this mutation score, and why really solves the mutation problems. Then, you know, to reach a high mutation score. So first of all, the first law of TDD says you are not allowed to write any production code unless it is to make a failing unit test pass. So in other words, we have to start writing with a failing test. So this law ensures in high level that every code we write, there is a demand for it, and every code we write a test also for that. Second, we have a second law of TDD. You are not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are also failures. And it means that this law helps us to take baby steps, because what we do is, you know, when we write a failing test, and once we have a failing test, which can be a compilation failure, we need to stop because of the second law of TDD. We need to stop, and we need to start implementing the code. Because if we wouldn't stop, then we would write a bigger unit test, which would require a bigger and more complex solution where the mistakes are easier to do, and we need to think more, and managing the complexity is even worse. So this law helps us to take baby steps. And the third law of TDD says you are not allowed to write any more production code than is sufficient to pass the one failing unit test. And this is one of the killing features of TDD, because it ensures that you don't write more code than your test satisfies. It means you don't write more code which wouldn't be tested. So it means once you pass the failing test, you have to stop. And that point is covered. And that point, if you would run mutation testing on the given code, given piece of code, then you would reach one high mutation score. So this is really the law, and this must be followed to get the benefits of TDD. And of course, if this law and any of the law is not followed by the TDD, not followed by anyone, then you won't get the benefit of TDD. Of course, there are exceptions, as always. We shouldn't be dogmatic, but 99% of the time, or 99.5% of the time, you need to follow these laws. And these ensure that you end up with a test suite you can rely on, and they have 100% code coverage and mutation score as a byproduct. So TDD leads to 100% mutation score, yeah, ensured by the laws of the TDD. The first law, we only write code if there is a test for it. And the third law ensures that we don't write more code than is sufficient to pass the failing test. So these two laws helps us to write really code which is covered by your test. And of course, seeing the test failing, another killing feature of TDD, because if you want to trust your code, you need to be able to trust your tests. And if you want to trust your tests, you need to be able to see them failing. And if you never see your test failing, you don't know if your tests are actually testing the right things. So seeing the test failing is as important as seeing it passing. The failing test validates the test is meaningful, unique, and fails for the right reason. So that's a killing feature of TDD, and you cannot have this without TDD, because TDD is the way where you start with the test. And if you don't start with the test, you don't see it failing. So you don't verify whether your test fails for the right reason. So another point for TDD. And of course, still, so the question is still, do we need to use code coverage tools? And yeah, we can use coverage tools, even mutation testing, but only as a quality checks, because most of the time they will be maximized values, so close to 100%. But of course, we are humans making mistakes. Sometimes we are tired, we have a bad day, we miss a test case, or we don't follow one of the laws of the TDD. Can happen. So in that case, we will have some missing assertions or test case. So these tools, namely the mutation score, mutation testing, will help you to find that issue. And now let's see mutation testing in action, or testing on development in action. Yeah, let's do it. So now let's check out the solution items README again. So here we have a specification, 𝗬𝗃 specification. So we already have a pick endpoint. Let's implement the 𝗬𝗃 specification in the last 10 minutes. So what we need to do is 𝗬𝗃 is add an 𝗬𝗃 HTTP post products endpoint, so post products ID 𝗬𝗃. Successful 𝗬𝗃 operation returns for 204 no content. When the product 𝗬𝗃ed, the latest pick state changed to 𝗬𝗃ed. I think that's straightforward. When the product 𝗬𝗃ed, the stock level increases correspondingly. Because what happens? What is 𝗬𝗃? Just again, so picking is, there is an order, we collect from the warehouse and we prepare it for delivery. 𝗬𝗃ing means when someone return back an order. So we have the products returned back. So we need to put back in the warehouse, and for putting back, we need to 𝗬𝗃 them. So it means the stock will increase. So therefore, it says the stock increases correspondingly. Return bad request when stock level becomes bigger than max stock level, which is 50. We can't have more than 50 products in a warehouse because physically it's not possible. So it's a business rule. And a bad request should have error, cannot 𝗬𝗃 more because reach max stock inventory limit. So this should be the error message in the bad request 400. So let's start it. And of course, the first law of TDD, you're not allowed to write any production code unless it is to make the failing unit test pass. So in other words, we have to start with the failing test. Let's start with the failing test. So for that, let me come here and let's start it. So the first one is we make a failing test that we spin up the HTTP server, we call it with the endpoint, and it should return 204. If I check again, yeah, 204, no content. Let's do that, the endpoint. So again, the test, public async task, 𝗬𝗃 should, yeah, I'm just calling it decrease stock level because that's the main behavior. And after that, yeah, that should be fine for now. So first of all, I'm creating, let's copy what we have here. So just to speed up, creating a scope, for in-memory test server, in-memory HTTP server. I create a product in a database via the scope. And now I would like to call it in an act. In an act, I would like to call it, and I'm going to call it 𝗬𝗃. The body will be nothing, 0. We don't care about body. Again, why don't we care? Why don't we pass it? We should pass the pick count, right? That would be. We already know that would be then, but no. TDD really forces you to take baby steps, and we can worry it later. Just focus on that. We spin up the web server, we call it, and we return 204 baby steps. And after that, we will gradually build up the application. It's called evolutionary design. So response, await. HTTP response assert that response has a status code, and here status code, I guess, no content, 204, if I'm not mistaken. Let's see. And at this point, we need to remember the second of the TDD, which says you are not allowed to write more of a unit test than is sufficient to fail. And compilation failures are also failures. And we already have a failing test, so we shouldn't write more assertions here. We could write, for example, hey, whether the stock level has been decreased, that's increased. But by the way, it was error, right? So whether the stock level should be increased or not, but we should stop here. We shouldn't write more assertion because it would lead a bigger problem we would need to solve. And the power of TDD is that we take baby steps. So we have a failing test. We can see why it fails, and it's a crucial point again. So we expect to be no content, but not found. This endpoint has been not found. So let's implement that. Jump to the production code, and here I'm just going to copy things because time is running. And here I'm going to call it unpick. Here I'm going to call it unpick. Here I'm not going to pass the payload, and basically I don't have it what we have here at all. And we just return 204. And we have a green test. But you see again, I don't run my test on the left. Please keep your eyes on the left and crunch window where we have all the check marks. So my test executed all the time. And you see the failing test has been green. And now we need to remember the third law of TDD. And this is the most important part of TDD. You are not allowed to write, we are following the third law of TDD, you are not allowed to write any more of a production code than is sufficient to make the failing test pass. Because here, if I would write more code, whatever, based on the business logic we need to implement, that wouldn't be covered by our test. So you would have a low mutation score for that. So that's how connects TDD with mutation score, that really TDD enforces you to take baby steps and stop at the right time with the production code, so all your business functionality will be covered. Very good. So the next will be, if I look at the requirements, it says, when the product unpicked, the latest pick state is changed to unpicked. Let's do that. For that, I can come here and just let me grab not the guy. Yeah, I have to get the product. I just want to copy code, but yeah, I can do it for you. It's easier. So product is equal, and here the scope, warehouse, in DB context, product single. So I get the product. And here the product last pick state should be, so I check whether the pick state, I guess, yeah, unpicked. Yes, that's the last pick state. And yeah, at that point we need to stop because we have a compilation failure. That's also failure. So let's fix it. So what I want to do here is, I would like to here create a new NO member in the picked. Yeah, it's odd that unpicked. And now I also need to unpick. And what I need to do is I'm going to the controller, not the controller, I said, yeah. So here we are. And what I want to do here, I just grab these things. So I get the product from database. I going to unpick. That's the minimum. And after the commit, let's create this unpick method. And the unpick method, basically what I do, I just change the state to unpicked. And yeah, we have a green test. Very good. Is there something to refactor? Of course, that's a crucial part of TDD, but I think nothing to refactor still. So we can go on the next one. And the next things to implement. When the product unpicked, the stock level increases correspondingly. So let's implement this. So for that, let me go to the test. Let me go to the stock level. First of all, let's pass the JSON. You will have to pass in the pick count. We have to pass in the body. And here we can put the JSON build new pick payload, I guess. Pick payload. Yeah, pick payload. And count should be, for example, 40. Very good. Here, I think there is one more. Yeah, pick load 40. And now, I get the stock level. The stock level should be 40. 50. Why? Because, we always have, when you create a product, we have 10, and that we already discussed. And if I unpick it with 40, then it should be 50. And as you see, we have in the error expected value to be 50, but found 10, which is the initial stock level. So let's fix it. And for that, what we need to do, have to go to the controller. No, in the unpick. Yeah, in the unpick, I want to raise an event. I want to decouple it from the data concerns. Product unpicked event. Let's create this event. Product unpicked event. So product picked event. Let me duplicate it. Let me call it product unpicked event. Very good. We have it. Let me change this. Just this. Oh, hey. Hello. Okay, cool. So we have this, so we can raise this, but still it is, we have to put the count there as well. Here as we also have to put the count, which is in the body with the payload. You know, we deserialize, we get it, and we get the payload, we get the count, so we pass to the unpick. After that, we pass it to the reason domain event, product unpicked event, but we don't handle this. Not sure why we have this error. We'll figure out later. So what I want is we need the product unpicked event handler. So let me copy what we have, the product picked event handler. It's called product unpicked event handler. Yeah, very good. Let me put this here. Let me put this here. Product unpicked. Yeah, and what we need to do, we don't need this here, and the stock level, we need to increase it. So here I can create increase the stock level increase method. I can go there and I can do like this, and here I can just put plus, and here let's call it count. Yeah. So now, yeah, there is one more thing, and I think that problem is that we don't have these dependencies, you know, with product the unpicked event and the corresponding event handler. We need to register it. There are solutions to not to do this, but for now, let's just totally keep this thing simple. Yeah, and now everything is green. So yeah, I know the time is up. So if you can allow me 2 more minutes, and after that I can finish this code example if it's fine by you, Ahmed. So then let's do it. If not, then up here. So here we are. So the next thing we want to implement is, yeah, the bad request when the stock level bigger than the max stock level. So for that, I'm just going to the test. And what I want to do is I'm going to copy everything just to speed up. Unpick should return bad request when bigger than max stock level, right? When new level, yeah, just to be better, when new level, bigger than max stock level, yeah, I'm doing this. I'm going to do 41, right? Because then it will be 10 plus 41, 51, which is more than 50. And what I want is here that bad request. And let's see, and we have a failing test. Yeah, we have a failing test. We check why, no content. So basically, we can still do that. I mean, we can unpick more than the max stock level. But if I go to the unpicked event handler, then here, what we need to do, we need to get var new stock level is equal the domain event of the existing stock level count plus the domain event count, so the ones we want to unpick. And if the new stock level is bigger than 50, then we throw new application exception. Great. And we have error because we still haven't handled this error. Here we have to do a try catch and make unpick. Yeah, and here we just say application exception. We don't need to pass, and here we just return bad request. Yeah, let's see, and we have a green test, and there is one more requirement where we need to pass the error message, but I'm not going to do that. No, we implemented. So as you see again, read me, we implemented everything except the last one, but just skip it. It's not a big deal. We just have to pass the string error message. So now we implemented this endpoint with TDD. Let's run the mutation score again. Let's see what we did. Let's wait it out. Yes. So as you've seen, the feature has been implemented with totally with TDD. We followed the 3 laws of TDD, which was crucial, especially the 3rd law of TDD, that we need to stop once we made the failing test pass. That's really crucial, because if we would write more production code based on the business requirements, then that wouldn't be covered by our test. So we would need to use mutation testing, which is time consuming. It's still a very powerful tool, but we could prevent a lot of cumbersome work coming from code coverage and mutation testing. So let's wait out the result, and after that we can go to the last slide of the slide sheet. So let me go there. Yeah. So here we are. I guess a new one should be generated soon. Yeah, last bits, yeah, and not yet, I guess. Report. And as you see again, domain is still 100%. And here we have this product unpicked event handler in 100%. So now because we've written it with TDD, and as you see in the previous one, we had 66 and very low results. So because we use TDD, we reach 100% mutation scores. We have nothing to improve, so we can trust our test because they are created with TDD. All right, so that was the practice, and that was how we use TDD. And now I can go back to my presentation. The last slide sheet, if you don't mind. Thank you very much. So again, conclusion. Without TDD, you need to use code coverage tools heavily. Code coverage tools, I mean code coverage tool and mutation testing. You need to use them heavily because you need to find these missing gaps, missing holes, missing statements, missing tests, missing test cases in your test suite. But if with TDD, you need to use coverage tools only for quality checks because we are humans making mistakes. So it's wise to execute these time to time. So it's a conclusion. TDD is the safest and the fastest way to write code. Yeah, that was it. Yeah, before we start the Q&A, there is one plugin. I recently created a TDD course where I talk about test-driven development deeply, all the things, testing best practices, clean code best practices, refactoring, and of course I talk about mutation testing and why TDD is the ultimate solution and the best way to write quality software. You can check it out at the 𝗨𝗽𝗰𝗴.com website if you are interested. And yeah, that was it. Thank you very much. And thanks that I could delay it with 5 minutes so I could wrap up my coding exercise. And yeah, looking forward to the questions.
Daniel, thank you so much for this great presentation and for this hands-on coding example. It has just the right amount of details. And it was very clear, whether that be the TDD practice or the mutation testing examples. That was simply great. Thanks a lot. And I think some of our audience share that. So Nariman thinks it's a great implementation. I know Nariman personally. She's a .NET developer. So she's happy that we finally did an example with .NET. Usually we're doing JavaScript or Java. So she's happy with that. Okay, so Khaled and I had a couple of questions prepared for you, Daniel, but I think we'll start with the questions from the audience.
Okay.
So we'll take the first question. It's from Safe, but his name doesn't appear here. He's saying, could you elaborate on what is a killed mutant? Now, I know you've explained this, but maybe he missed it. So let's just...
Absolutely.
Yeah. Thank you.
So again, you can have killed and survived mutants, and the killed mutants is the one where, so again, we generate, so let's do simplest way explanation. Let's say you generate a modification of your code, you negate a boolean, or let's say you delete a line of code, that's one mutant. And if you run all your tests, so you delete that line of code, and if you run all your tests, and if you have at least one failing test, it means your tests are strong enough to find that bug. So it means that your test kills the mutant. So that's a killed mutant. So killed mutants are the ones where if you do it, you introduce it, you will have a corresponding failing test. So killed mutants are good because it means our tests are strong enough to find this artificial change, modification, or bug in the code.
Okay, so thanks a lot for that, Daniel. Let's move to another question, again by Safe, but on YouTube instead of LinkedIn. So that was related to something you were doing in your hands-on example. So he was asking, by in-memory test server, you mean making an object where it has all the endpoints of the implementation object, but with mock data?
So this is... So here I use the ASP.NET Core Test Host library. You can check it out. It's from Microsoft, ASP.NET Core Test Host, and it has a test server object, but it's it's natively provided by this library. And you can spin up your .NET Web API in memory, so it does it. But going for the mock, I'm using. Yeah, I forgot to mention. I used an SQLite database, but that's also in memory. So that's everything in memory. But going back, so the test server, you can use ASP.NET, ASP.NET Core .test host library. So that you can use to spin up HTTP servers in the memory. So that's what I used. And of course, I use SQLite, not I don't know, PostgreSQL database, because SQLite you can spin it up in the memory, so it results in a fast tests.
That's great. Another question by Saif. He was asking, how do you calculate code coverage? Is it by the used objects and functions? And does the 𝗠𝘂𝘁 tool, he actually meant tool, not library, handles the calculation of the code coverage? This is actually a good question.
Is it by used objects or function? Yeah, I think the code coverage is reasonably calculated, but which line? So how many lines of all of the lines of your code base has been executed, touched? So you invoke it by your test. So it's by line. I don't think it's object or function level. It's line by line. Whether the given line of code is called by your tests, then it's increase the coverage. If that line is not called or not executed by your code or by your test, then it's not included in the calculation. And I think that's how all the based on my knowledge, that's how code coverage tools works. It just checks the lines which are touched or executed by your test or not, and compares the difference.
Okay, so I want to add something to your answer, Daniel. So we all use tools, as you've said in your presentation. There is no point in reinventing the wheel. Tools make our lives a bit easier as long as we are using the tool and the tool is not using us. But here's the thing about testing tools, okay? Sometimes they don't get the terms right or the concepts right, okay? And let me tell you something, Saif. Now, code coverage as a concept, it has many different metrics: line coverage, branch coverage, function coverage, statement, and path coverage. Okay, so what you need to do is first understand what each coverage metric does under the umbrella of code coverage, and then compare that to what the tool does, okay? It will give you a better understanding. Now, I'm not a .NET expert, so I don't know what 𝗠𝘂𝘁 does exactly and how it calculates the different coverage metrics. But I suggest that you read first about the different types of code coverage metrics and then compare that to what the tool does, okay?
Very good.
Yeah,
very good. You totally nailed it, and you're right. I think 𝗠𝘂𝘁 just quickly checked out. It just checks the lines, but you're right. There are tools which checks these branches, all these things. But so I didn't know the answer whether the 𝗠𝘂𝘁 does it or not, because I'm not interested in the code coverage. I stopped in the last 4 or 5 years. I don't care about code coverage. If someone tells me 100% code coverage, I don't care. It does. Of course, it tells me which are the piece of code which is executed. That's it. Doesn't tell me anything. Tell me the mutation score. That's what I'm interested. And mutation score also includes, in some sense, code coverage. So therefore, in the last few years, I mean, even in the projects or companies I work for or help, we just, even in my previous, in my current one where I joined to help them, we just ditched code coverage. We had it in GitHub, as a message, in every CI build, we had that as a message, a comment, in your GitHub PR, what is the code coverage. But since we talked about, and I told them what is mutation testing, why it's not the best metric, and it doesn't make sense to strive for 90%. Let's strive for don't write test to increase code coverage, write test to gain confidence. So we totally ditched it. So it's good, but it's good to know, important to know, but don't get lost in code coverage. Get lost in mutation testing a bit, but after get lost in TDD.
Yeah, that's a great point. Thank you for that. We did a session 1 or 2 months ago with Paige Watson. It was about using TDD to tame legacy code.
Okay.
And
cool.
I remember one of our attendees asked, how can you tell if the tests have covered the functionality that the code does? Because with legacy code, the code is already written, and you need to write some characterization or pinning tests for that code. approval tests. Well, there are lots of tests
Yeah.
you can write for legacy code. And I remember Paige said that one of the things you can use is code coverage. So this is actually making use of something most of us think that is useless.
Very
But
good point.
I like the idea. Of course, you can't rely on it alone, but it will give you an idea. Let's say the legacy code is too big and you've scanned it, but still you may miss a couple of things. I think code coverage will work fine in that case. So this is basically just to say that it's not totally useless. There are uses of code coverage, but to measure the quality of your tests, maybe mutation score is the golden score or the gold standard, as they say.
Absolutely agree.
Okay, so let's move to a question from Nariman. So she's saying, can you explain, and I like this question, can you explain the significance of achieving a high killed mutant rate in mutation testing and its correlation with the overall reliability and robustness of the software being tested? I'm waiting for your answer, Daniel. That's a good question.
Very good. The reliability, absolutely. So if you achieve a high, achieve a high killed mutant, it means that all the modification which has been created is covered by your test. So your test suite is strong enough to find any bugs. You can introduce regression bugs in the future. So it makes your test reliable. So that's absolutely. It's really the higher it is, the higher the killed mutants, the more reliable your test suits, and the more reliable, the more you can trust. That's totally. On the other hand, the robustness, I don't think a high code coverage. So I don't think a high killed mutants correlates with robustness, because robustness is whether let's say also that if let's say if you couple your test to implementation details, and if you, for example, change some, if you refactor your implementation details and you have a failing test which fails because you refactor, not because you introduce the bug, then it's not robust, right? So code indirectly, that's a good question, because you can have, as you've seen when I generated the mutation score, it generated 140 mutations, but you've seen the half of them was not included in the calculation. You remember, some of them were because ignored, but a few of them returned compilation errors. So maybe that could increase a bit. But apart from that, I don't think so. Killed mutants, high level of killed mutants won't tell you if your test is robust or not. It will tell you whether it's reliable. I think robustness is another thing, and I think for robustness, it's just you need other techniques and focus on behavior. I would say that's the best thing. Focus on high-level behaviors and public APIs. You just public APIs and test the behaviors, and don't couple your test to implementation details, and don't test, don't couple to functions, no private functions, surely. So try to think about what's the behavior of your system, and find the public APIs and write your test for that, so you can have a robust test suite.
Yeah, I fully agree with what you've said, Daniel. I wanted to add one more thing. Now, Daniel has explained in his session, Nariman, that TDD and mutation testing are both techniques that work together very well, okay? And mutation testing basically measures the quality of your tests. Now, if you're measuring tests that you've written using TDD, then you're making your TDD practice better. And as you've said, Daniel, TDD is a design and development approach, okay? In addition to being a testing approach, well, this is a bit controversial, but I know there are opinions. So yeah, we'll go with that. But here's the thing. If you're doing better TDD, Nariman, you will definitely have more reliable and more robust software. Okay, and if mutation testing is going to help you write better tests, and these tests drive your design and your development, then overall, the mutation score you're getting is helping you build more reliable and robust software. Okay, so there's a relationship between both techniques, and they both help you at the end get high quality software. I don't know if you agree with me, Daniel, or not.
Absolutely, couldn't agree more.
Okay, thank you very much, Nariman, for that. I think we'll take one more question from the audience, then we'll move to the questions that Khaled and I prepared. So, Laurent, I hope I'm pronouncing that correctly, saying, I love to write unit tests in isolation. Mainly, I touch one class and one test class. Exceptions are the enums, exception classes, etc. Would it be more clear to use isolation for TDD? Now, I picked that question because I wanted you to talk a little bit about isolation.
Very good, very good question, Laurent. So the thing is that there is two schools of TDD or testing. You have the Chicago school and the London school. And the Chicago school, and that's what I have shown to you today. I really targeted behaviors of my systems, and I didn't care about the class level that much. Of course, in this case, product control layer, but that's the highest sort of the public API. But I didn't care about other class, the product class. I didn't write test or the product fin there or other things. I focused on big, it's called solid-state tests. And for isolation, that's the London. So we have the Chicago. And we have the London School of TDD, where they isolate the components, or isolate the classes, and they mock out all the dependencies and all the collaborators which the class collaborates with. And yeah, both of them the advantages and the disadvantages. But I don't know, in the last almost 10 years or 8 years I'm using TDD, that I realized that the classicist school is way better than London. I know people who are still using London and they like it. My problem with the London, so the good with London school of TDD, so isolate your stuff, that you really focus on one thing and you really don't care about what happens outside of your class. And if you don't need to implement it, you can delegate decisions. It really helps you to verify your micro decisions you do with a given class. So that's why London school can be beneficial. But the disadvantage, which is very huge for me, is that really you couple your test to implementation details such as functions or even classes. Those are implementation details. And if you couple them, then it will prevent you. If you couple your test to the implementation details, then they will be fragile. And fragile tests will frequently break during refactoring. And for me, the most important part of TDD, or the most significant part of the TDD cycle, is the refactoring, because there I really build up the design gradually by practicing continuous refactoring in small steps. So I'm continuously refactoring the code. And if I follow the London School of TDD, so if I isolate everything, every piece of thing, then those tests can easily fail. And in the refactoring, I don't want to have test failing because the structure has been changed. I want to have test fails only if I change the behavior. So therefore, you can do it. You can be successful. I just really prefer, and also in my circle and what I've seen on the internet and other friends, then more and more people are really, jumping and preferring the classicist school, which is called Detroit School of TDD, where you focus on behaviors. There are exceptions, and there are where you need to also verify interactions, because that's what London School and this isolation is doing, right? You focus on the isolated things, and the interactions maybe you care about a bit, but after that you don't care about what is outside. So I go for the classicist always. So I don't really. Sometimes, of course, you need to verify. You need to verify, interactions. And there are exceptions as well when I need to delegate some implementation decisions, but they are very rare. So they are really exceptions. So most of the time I would go for testing bigger units. So big test, writing big test for a big class, which uses 5 other classes, and those classes also using other classes. So all in all, you can have 10, 20 classes, but you focus only the highest level, the public API, the functions, or the highest level public APIs of the highest level class. So that's my take on this.
Great answer, Daniel. Thank you very much for your insights. Okay, so now we'll move to the questions that we had prepared. There are only 5 questions, so don't worry, we're not taking a lot of time. Khaled, you have a question, please proceed.
Yes, Ahmed, thank you, Daniel, for the great presentation. So, as you know, Daniel, some people argue that mutation testing can be an overkill for smaller or simpler applications. And in which scenarios would you not actually recommend implementing mutation testing, and how do you justify the trade-offs?
We can even replace the mutation testing with TDD, but the answer is the same. So you should use mutation testing and TDD on code base where you want to have a code base with high quality, where you want to trust your code and it's for the business. So if you want to write code where you are not confident that it works, where it's not clean, it's not well designed, where you cannot add new features because you don't trust your test suite, then you shouldn't use TDD or mutation testing. So I would say doesn't matter it's big or small. It's not about whether small or big. It's about how significant the use case is. If it's used by the customer, then I use mutation testing and TDD because I care about my customer. My biggest goal is to make them happy. That's the ultimate goal, and I can also only make them happy if one of the ways not to make them sad is not to introduce bugs. And how can I prevent bugs is to use mutation testing and TDD. So therefore, I mean, it's not about small or big. It's about I care about the customer or not. And most of the time I care about the customer and I write software for customers. So I don't think mutation testing or even TDD is overkill in any kind of project where it's used by the customer.
Thank you very well. I appreciate this answer. As you shown, Daniel, that mutation tests focuses on test quality by introducing subtle code changes that are mutants, etc. And there could be many mutations, as you in the code example you shown there were 86. So how do you recommend balancing the computation cost of running mutation tests? Well, especially in large code bases, how do you recommend balancing that with the benefits that it provides?
First of all, let's say you have a project where you have a low mutation score. So you need to run a mutation, but also it's a large code, so you need to generate a lot of mutants. But surely, first of all, focus on fixing it. Focus on fixing the mess. So it means you need to run mutation testing, mutation score. You have to check and have to improve your test because if you wouldn't improve, then there is a high chance that you will introduce bugs. So first, reach that you have a test suite that you can rely on. But after that, still, if you keep executing it, it will be time consuming. So you can do that. So do the mutation testing. After that, do TDD. So you keep the mutation score high. And after that, I would recommend to not integrate it into the CI in your build CI, or which deploys, for example, right away to some testing environment or even to production. But to have some separate, you can, if it really takes a lot of time, then do it in a separate pipeline. So trigger a separate pipeline for that. So no, don't make it, because it can be so it depends how frequently deploy, or depends how frequently or how fast you want to deploy. If there are Steams or Amazon multiple deployments per minutes, or they are really hardcore. Therefore, you can't let running mutation testing for half an hour, 1 hour. But if you can let it run in the CI build, but even that, I think the best answer is to have a separate pipeline for that, which is triggered by your main CI pipeline, and that can return some message in a GitHub comment, or send email, or in the dashboard it can put the result, so you can keep eye on it. And if you see somewhere there, but most of the time the ideal solution is that you have the high mutation score, you solve this. So first of all, solve that. After that, you keep using TDD. So you keep the high mutation score, and you have after that these mutation results in a separate pipeline, and they will be always very high. So you don't need to do anything, just as a quality check. So that I would risk die for, because if you don't do that, if you don't do TDD, if you increase the mutation score but you don't do TDD, then you will have a lot of survive mutants. So you need to change them. You need to spend time on it. In cumbersome, time consuming. You don't want that. You want to keep the quality high, and you can keep the quality high. TDD is one of the best way to keep the quality high. So I would say this is what I would balance. A separate pipeline makes sense for large projects.
Very well. Thank you, Daniel.
Thank you too.
Okay, so let's move to our next question. So, Daniel, TDD and mutation testing complement each other well, but TDD often gets misunderstood. In your opinion, what is the biggest misconception about TDD that developers or teams need to overcome to fully adopt it?
I think so. First, surely most people don't know what significant number of people, I mean, more than 50% of developers don't know what TDD, which is really sad. Really, it's literally they don't know. They will say it's testing, still up to this day. But the biggest is that many people think that TDD is something that you take and plug it to the development process and it will work. And it doesn't work like that. So for TDD, you need so there are requirements for TDD. You need I would say 3 things prior or in advance to be successful with TDD. First of all, you need to know how to write tests with the framework. I think most of the time it's really given, but still, a lot of people still don't know how to write tests, which is best libraries, etc. And also the second is you need to know how to write clean tests. Again, tests which are not coupled to implementation, they are readable, they are treated as first-class citizens, etc. With good, so clean, write clean code or clean tests. And the third one is how to design software. And that's what a lot of people miss. You need to know the design pattern. You need to know the code smells, architectures, all these things, architectures, because they also can also support the TDD flow. So you need to know this design and testing skills. You need to have this to be successful with TDD. Because if you don't know this, then TDD won't work. TDD won't tell you which design pattern to use. It won't tell you how to name your software element. It won't tell you whether you should create a class or no. It can give you warnings when something is wrong. It can give you directions. It can give you safety net. It gives a lot of things, but it won't tell you. TDD gives you feedback. It doesn't tell you what to do. It gives feedback what you do. And therefore, again, you need design skills and testing skills and very good, I will say very good ones. So good ones. And if you don't know that, don't know those skills, first of all, fix that. But you can do TDD next to it. But I would say this is the biggest misconception that a lot of people think, okay, TDD, let's use it. And they use it. They don't know how to write clean tests. And after a few weeks, they say, hey, it doesn't work. I have a lot of breaking tests. And usually the reason is that they couple to the implementation details, for example. And after that, they discard the whole idea of testing and TDD. And they blame TDD, but they should blame themselves. So this is the biggest misconceptions that you need. They don't think that they need some knowledge beforehand. You need to know how to write clean software.
Yeah, in my recent TDD anti-pattern session, one of the anti-patterns I mentioned is hasty implementation. So yeah, indeed, you need to do some reading before practicing TDD. As you've said, about writing clean code, about refactoring, about working with legacy code, how to write good clean tests. Otherwise, the experience is going to blow up in your face, and you're basically going to drop it and lose the value it can give you. Yeah, that's great. Thank you so much for this answer, Daniel. So moving to my next question. So again, referring to my TDD anti-pattern session, I often reference a tweet by 𝗨𝗽𝗂𝗁𝗃, I hope I'm pronouncing that right, from a few years ago, where he expressed surprise at how many experienced TDD practitioners didn't see the value in mutation testing. Why do you think some developers struggle to recognize its value and importance?
I wouldn't say interesting. So most of the people, I don't think they are struggling. I think there is a lack of knowledge of this about mutation, lack of knowledge of people who are preaching, and lack of people who are advocating TDD and mutation testing. Not so many people, and unfortunately less and less. So less and less software craftsmen. Also with the AI, everyone thinks AI can write the software for us, which is true in some sense. We can be, I mean, it's incredible what AI can do for us, but still it won't fix all problems right now in the next 5 years, but let's see, maybe later. Yes. So the most, I think the thing is that somehow we have a lack of knowledge and people just don't care. They get their salary regardless, high salary, because we work in industry which has high demand for any developer. Basically, even bad developers can find jobs if they are persistent enough, and they will get the salary without TDD and mutation testing, and they won't be fired if they have a bug, because of course, which is normal. I don't say that we should fire people if they have a bug or if they don't use TDD, but we should sort of fire them or warn them that if they don't care about the quality, because it's all about the customers, all about making them happy, and you can do it with high quality software solution. You cannot do it with low quality, and TDD and mutation testing enables high quality software solution. So I would say again, the struggle, I would say it's not about struggling, it's rather about just the industry is not going into the direction that we really care about quality. We want to just throw out or want to just spit out code in one day, 24 hours, and we have a functioning web application, and they care about money. But a low quality product can it can lose a lot of money because it's low quality. So, but that's another topic, I would say.
Yeah, I fully agree with that. Thanks a lot for that, Daniel. So we've come to the end of today's live episode. Daniel, thank you so much for taking the time to do this episode with us. It has been a pleasure, and great job with the presentation and the coding example. As I've told you, was simply great. I know you're busy preparing for a big event with Tech Excellence. So again, thank you very much for taking the time to be with us, and good luck with the event. We'll definitely be attending, and we hope it will be a great event. Daniel, myself, and Khaled, we all teach TDD. So Daniel has shown his great courses. I highly recommend you buy them. They're excellent. And what I like about them is that they don't just touch the basics. They teach you how to do it for web. They teach you how to do it for APIs, back end. It's really great. Daniel is really great with the details. So highly recommended. Khaled and I do TDD workshops, a fundamental and advanced workshop, and we teach mutation testing as one of the topics. So if you want us to deliver this workshop for you, just contact us on techcafe.com, and we'll be happy to deliver that. Daniel, thank you so much. And to all our audience, thank you very much for being with us, and see you next month in a coming episode.
Thanks again. It was a pleasure. See you, everyone. All the best.
Thank you. Bye-bye.
Thank you.
Thank you. Bye-bye.